Hey everyone, we are going to start our first lesson on integral calculus today, and this is going to be a brief review on the lesson 25 from our manual. Okay, so indefinite integration is lesson 25, and really what we're talking about when we're talking about indefinite integration is we're now going to start to talk about the concept of the inverse. We spent all of the first semester, or inverse operation, we spent all of the first semester talking about derivatives, and it was all derivatives, derivatives, derivatives. Well, now what is the inverse of taking a derivative? In pre-calc, we talked a lot about inverse functions, how the inverse of addition is subtraction and vice versa, the inverse of multiplication is division, the inverse of squaring is taking the square root, and so on and so forth. So since differentiation of a function is a process, there has to be an inverse to that process, and that process is anti-differentiation. Okay, so it is the inverse of taking the derivative, anti-differentiation. And you can read along through this on your own, but basically, let's take a look right here. Let's say you have the function x to the third and you take the derivative. Well, the derivative is 3x squared. Let's say you have a function x to the third plus 1 and you take the derivative. Also 3x squared, because the derivative of a constant is 0. So on and so forth. The derivative of all of these is 3x squared, because it's x to the third plus a constant or minus a constant, and you're going to get the same derivative. So that's the differentiation process. The anti-differentiation process is taking a look at this function and saying what was the function. This is the derivative, what was the function. So we take the anti-derivative. And since we know all of these came from some form of x to the third plus a constant, or just x to the third, we know that it's x to the third plus c. And there are rules and stuff, and they'll make sense in a few minutes. But c represents an arbitrary constant. Since we don't know what c it is, it could have been 1, it could have been -4, it could have been 2 pi, it could have been anything. We know that 3x squared is the derivative of x to the third plus some number c. Okay? So we're specifically calling it in this section indefinite. We're specifically calling it indefinite integration because of that constant c. So the process of taking the antiderivative is called integration. And we don't really, we use the word antiderivative, it's the process of taking the antiderivative is called integration. But really what we just did here is we integrated. Okay, we integrated. We took the antiderivative, we integrated. And what we're doing is right now is indefinite integration because we don't know what that constant c is. The symbol for integrating is an integral sign, which looks like this. And the way we write an integral is we say the integral of the function, so the integral of f of x, and then we write dx. Dx tells us the variable of importance, just like when we were deriving, we wrote dy dx, which said we were taking the derivative of y with respect to x. Or when we were doing related rates, we wrote dy dt because we were taking the derivative of y with respect to time. Dx tells us the variable of importance, okay? So go ahead and read the rest on your own, and what I'd like to do next is go to the next page and look at the integration rules. All right, so what I like about this chart is that it shows you the derivative rules and it shows you the integration rules, and you can kind of see how they are inverse operations of each other. So the derivative of a constant was equal to 0, which means that the integral of 0 is simply a constant. And notice how it's integral of 0 dx, because x is the variable of importance, but the derivative of a constant is 0, so the integral of 0 is a constant. The derivative of kx, where k is a number, so let's say like the derivative of 2x, was just 2, or k. That means the integral of just k is kx plus c. Notice how we're integrating these answers. All right, and let's do that one more time. We're integrating a constant, k. Well, the integral of k is kx plus c. Why plus c? Because if we took the derivative of, let's say, 2x plus 5, I wanted you to take the derivative of that. The derivative of that would simply be 2. So that's the same as the derivative of just 2x. The derivative of 2x is just 2. So when we integrate 2 dx, we know that the integral of 2 dx is 2x, but it could have been 2x plus 5. It could have been 2x plus some kind of constant. We don't know. So plus c. All right, the derivative of a constant times a function is equal to the constant times, the derivative of the function. All right? So what that's saying is we factored out a constant. Let's see here an example. So let's say you have 2x squared, and we took the derivative of that. That was the same as holding 2 and taking the derivative of x squared, which is 2x. And you guys quickly do this, as the derivative of 2x squared is simply 4x. Because you took this 2, you brought it down and multiplied it to that 2. Well, technically, you held him, you took this derivative and then multiplied it to that 2. Constant multiplier, right? So when we take an integral, we can do the same thing. We can take that constant out. So if you're integrating 4x dx, you could take the 4 out and simply integrate x dx. And then I'll show you how to do that in a second. Okay. All right. So where are we here? So that's this one. All right. So the derivative of a sum or difference was the sum or difference of the derivatives. Same thing for integrals. The integral of a sum or difference is the sum or difference of the integrals. So if you are integrating, let me make myself some room here. Oh, I didn't want to do that. If you are integrating x squared plus x to the 5th dx, you can integrate x squared plus you can integrate x to the 5th, and right, dx is on both of those. Okay, so that's what that other rule says. And yeah, and last but not least, the super important power rule, which is the meat and potatoes. In deriving our power rule, when we took the derivative of x to the n, was n x to the n minus 1. When you're integrating, it's x to the n plus 1 over n plus 1. X to the n plus 1 over n plus 1 plus c. So if we go back to taking the integral of 4x dx, I could take out that 4, and I'm taking the integral of x dx. And the integral of x is x to the n plus 1, so x to the 2, over n plus 1, which is 2, plus c. All right, so if I clean that up, again, I did x to the n plus 1 over n plus 1, multiplying by my constant multiplier 4 that I just pulled out. I end up with 2x squared plus c. And you can do a quick check. This should be the derivative of, I didn't spell it right, the derivative of him. We had the derivative, we found the function. Now that we have the function, take the derivative and see if you get right back here as you're new to this. So what I'd like you to do is I'd like you to see from these 15 how many you can do. Some of these are tricky. I'll do a few of them with you, but I want to see how many you could do on your own. Let's take a look at 5. All right, we do have a sum here, so we could do the integral of t to the 3rd dt plus the integral of t dt plus the integral of 1 dt. All right. So the integral of t to the 3rd, that's just going to be the power rule for integration. That's t to the 4th over 4 plus t to the 2nd over 2 plus t plus c. Now let's go through that one more time. Power rule, t to the 4th over 4. Power rule, t to the 2nd over 2. The integral of 1 is t. How do I know it's t and not x? Because it's all dt. And if you derive t, you will get 1. So the integration of 1 is back to t, plus our arbitrary constant c. Always and forever your arbitrary constant c. Take the derivative of this, and you should end up right back here. I've gone ahead and set up number 9. It is a sum, so I split it. Remember that e is a number, so you're taking the integral of e to the x dx, which is e integral of x dx because e is a constant. So it is ex squared over 2, applying a power rule on that x, plus the integral of 1 over e. 1 over e is also a constant, so the integral of a constant is constant x. Okay. Again, you're taking the integral, you're pulling out 1 over e, let's say, and you're taking the integral of 1, which is simply x, because the derivative of x is 1. So 1 over ex. And let's not forget, plus c. You may need to see that one more time and go back to the chart to review which rules we used. So again, I'd like you to try as many of these as you can, and I'll open the floor for questions tomorrow in class. Try these if you like that. Try as many of these as you can from 1 through 15, and I'll open the floor for questions tomorrow in class.